All right, we are continuing on with section 13.1, and we are doing problem number 8 now. So we are given the derivative f prime of x equals x times x minus 2 over x squared plus 1. So we're to identify the critical values, and then we're to determine what intervals the function might be increasing or decreasing on. And then, once we do that, we should be able to surmise if the critical values that we've identified are in fact relative extrema, either a relative maximum or a relative minimum. Alright, so the critical values here are x equals 0 and x equals 2. The denominator here is never 0, so we're good there. So critical values, x equals 0 and x equals 2. So let's set up our little chart. We've got 0 and 2. We've got an interval between 0 and 2. We've got an interval negative infinity to 0. And we've got an interval 2 to infinity. Now we're going to examine the various components of the derivative that will be relevant in terms of identifying whether the derivative is positive or negative. And then once we do that, we're going to figure out what it is. So it's good to have a row here that that will help us keep track of that. All right, so between 0 and negative infinity, let's throw in negative 1. If we plug in x equals negative 1, that's going to be a positive value. And we plug in x equals negative 1 in the second component of the derivative, we're going to get a negative value. So positive times a negative will give us a negative derivative, and that means that on the interval negative infinity to 0, the function is decreasing. Alright, let's now look at this interval between 0 and 2. Let's throw in 1. If x equals 1, the derivative is positive. If x equals 1, 1 minus 2, the derivative is negative. So that means the derivative is negative in this interval between 0 and 2, and thus the function is still decreasing. So we've got decreasing. That means 0 is not a relative extrema, because to the left of it, the function is decreasing. To the right of it, the function is decreasing. So there's no change in behavior. That means the point is not a relative extrema. Now let's look at 2. We've identified the fact that between 0 and 2, between that interval, the function is decreasing. And thus now we can look at the interval between 2 and infinity. What is the function doing there? So let's plug in 3. X equals 3 is positive. X equals 3 minus 2 is positive. So that means the derivative is positive. That means the function is increasing on that interval, and thus 2 is a relative minima, because to the left of it, it's decreasing, and to the right of it, it's increasing. So we have 2 as a relative min. Just call it a relative min. And that's it. That is the end of problem number 8.